So we need to go on. The next presentation is made by our French friend, Julien Rouhaud. Hypothetical Partitioning. You are kindly welcome, and please ask your question in the end when our friend will get his...
Hello everyone, thanks for coming to my presentation. So I will talk today about version 2 of HypoPG, about hypothetical partitioning support for Postgres. So a quick introduction of who worked for this feature for the version 2. So I'm Julien Rouhaud, so I'm from Paris, France. So you probably noticed I have a weird accent, so if you don't understand what I'm saying, feel free to ask me to repeat. So I'm working on some extensions, so HypoPG, Power extension, to try to help DBA to optimize their workloads and give them enough insight of what's happening. And, oh, sorry. Is it better? Oh. Okay. A bit too loud. And the second person is Hosoya Yuzuko from NTT in Japan. So at first it's her idea to do hypothetical partitioning. So we worked together for almost a year for this feature for many reasons. One of them is the declarative partitioning in Postgres like totally changed between version 10 and version 11, so we have to change everything ourselves and then go back to support version 10 again, so it took quite a while, but we finally did it. And so she's helped me on HypoPG, and she's interested in the partitioning and the planner part, so thanks a lot to her for help and work. So I was planning to talk about many things and also doing a quick demo, but I don't have my own laptop, so there would be no demo, but everything else would be there. Okay. So HypoPG. So has anyone already tried it or used it for tests or on production, or does some people already know the extension? No one? Great. So I can introduce you to this extension. So you have the link if you want to try documentation or clone the repository. Oops. Okay. So the idea of HypoPG at first was to support hypothetical index, which is a way to create an index without really creating it. So you just add metadata to some kind of memory catalog, and then you can ask Postgres, I have my bad performing query, and I want to know if this index I think would be helpful, will be used by Postgres, and how it would be used. So this allows you to do that, so you can help you to decide which index to create, and you say, oh, I maybe have 2 or 3 different indexes to do, which one is the best. You can check and ask Postgres how it will use it. So the version 2 of HypoPG is basically the same, but for partitioning. So for declarative partitioning, which was introduced in Postgres version 10. So idea is exactly the same. Like you have like a huge table with billion of rows or terabyte of data, and you say, oh, now I'm in Postgres 10, and probably I could have partitioned it to have better performance. But if I do it now, like it would take like days to recreate it from scratch. So before doing that, I want to make sure my queries will actually benefit from this new partitioning scheme. So with version 2 of HypoPG, you can try like 2, 3, 4, like a lot of different partitioning scheme, test your production query on it and see how it will behave, and say, oh, maybe I will partition by date or anything, and you will see if you can get better query plans. So declarative partitioning was introduced in Postgres 10. So so before in Postgres 9.6, you could do some kind of old-style partitioning, which is like inherited tables with homemade triggers to rewrite the queries on the target tables. You have to make your own constraint and everything. So it could more or less work, but it was a little bit slow and painful and error prone. In version 10, you had partitioning, so with only so DDL support. You can only do range and list partitioning. But the good thing is really faster than the old style partitioning, and also you don't have to create yourself the triggers and everything, so it's really better. And like version 11 and version 12, which will arrive probably in fall of 2019, will be even better performance. So there are a lot of work being done right now, so it will be even better. So the declarative partitioning is behaving really fast and better than old style, but if you want to really benefit from it, you have to wisely choose your partitioning scheme. So you have to ask some obvious question, but like which table should you partition, which strategy, like hash, list, whatever, which column or columns, and would you want to do like sub-partitioning or anything? How many partitions? So all of that is a question you should ask and probably try before putting production on it. So here it is. Some features working either on Postgres 10 or 11 or upward. So the partition pruning. So this is a very simplistic example where the date is like a string, so it's supposed to be a real date and timestamp everything. So you see you have your order tables and you say, I want to have 12 partitions for every month, and you say, oh, I want all the orders ordered in January. So Postgres will only scan the first partition and skip everything else, so it's faster because you only scan 1/12 of your data. So in this case, obviously, you would like to partition by date to be able to get a better performance. Partition-wise join, the idea is you have like, once again, a lot of partition, and instead of joining the whole table, you join partition by partition. So you could do like a 12 join instead of one big join, which will be faster and can be parallelized. So in this example, again, it's on the date, like between orders and customers. Oh no, it's on customer. So on this example, what you would like to do is partition by customer ID instead of date. So it's, for this query, it's different partitioning scheme. Partition-wise aggregation. So still the same thing. So here again, you want to partition by date, so you can aggregate here month by month or day by day or whatever you need. So the question is now you have like 2 or 3 different queries which would require like different partitioning schemes. So which one should you use? So it can be hard, especially if you are DBA and not the developer of the application. You kind of discover the queries as they are arriving to your database. So the only tool you have is logs of queries and explain plans. So I will show you with HypoPG2 how to test everything with the different partition scheme you want to try. First, introduction of the SQL API to use hypothetical partitioning. So it's like a user-defined functions. So you have one each HypoPG partition table. It's more or less the same grammar as what you would use with a declarative partitioning. So you just date your table name, and then you choose a partition by clause you would use. So in this case, it's partition by, so for instance, a hash on your ID, for instance. And once you, like, the table name should be your real table. And once this is done, you can call HypoPG add partition for the root table name, and then you specify the partition of and the values to declare your different partition. And also you can add a third argument, which is another partition by, which you can use to do multi-level partitioning. So you can partition your partition. So this is exactly the same as declarative partitioning, but in slightly different way. Oops. Now there are some problems when we try to develop this. It's how to get good estimates, because for hash partitioning, it's quite simple. If you say I have 10 partitions, like each partition should be a tenth of the data. But it can be more difficult for other partitioning strategy. So for hash partitioning, what we do is just get the modulus, and then we can compute the fraction of the tables. So here I have like a weird example. One is modulus 10, the other one is modulus 5. So you have different fraction of the data in each partition. Now for range and list partition, you can't do something as simplistic as that. You need really more knowledge of the data, and you have to ask Postgres to estimate it. So in this example, you have the T1 table with a constraint, so partitioned by on the ID column. So what we can do in this case is we can try to use a selectivity function from Postgres. And for instance, if we have a range partitioning for ID 1 to 10, we can just ask the selectivity function what should be the estimate of number of rows and size for these predicates. And Postgres could tell that, but it's naive, but it has some problems. Because if you do sub-partitioning and list partitioning, you have to accumulate a lot of predicates. And in this case, Postgres would just multiply the selectivity and just get like very wrong results. So we couldn't use this strategy for good estimation. So instead, what we did was to create a new function, which is HypoPG analyze. It's similar to the analyze command, but it's using the hypothetical partitioning scheme to try to deduce what should be the data in each partition, and then get a sample for analyze purpose, and then store it in a local memory. So be careful if you use it. You have to call it yourself, because obviously AutoVacuum will not call this function. So how to use this function? You just call HypoPG analyze on your table name. You specify a fraction of tuples. So I think it's 10% by default, but you can choose anything. And then the function will iterate over every partition and sub-partition and do the magic and come up with the results. So technically, what it will do, it just goes through all the partitions, all the level of partitioning, try to generate a complex workflows for all the partitioning key for each level. So for instance, on the orders, first is partitioned by date and then partitioned by customer ID. So for the top right partition, you will have like date is January and customer ID between 1 and 1000. So you come up with those predicates, and then we just generate this workflows, which is the same as the predicates, so undid predicates. And then we just use table sump of features from Postgres on the root table, and we append all the predicates. So we get the data corresponding to this specific workflows, and we tell the estimate, the analyze function of Postgres, this is the whole data, and come up with some statistics. Oh, sorry, it's getting... So we get this workflows, we get the table sump features, so sampling, filtering with the second parameter, so here 70%. And then we compute the statistics. And that's all. And we store that in a local memory. So technically, it should be able to work on a standby or a primary server. But for now, it's not, because we have to get an OID, like a unique identifier for each object. And getting an OID is a write operation, so you can't do that on a standby. But we plan to fix it at some point, so you could use it on a standby. And And that's how it's working. So the exception is for hash partitioning, because the problem with hash partitioning, it's a very specific function declared in the Postgres catalog, which does some kind of tricky operation which we don't really support. So what we do if you have multi-level partitioning involving hash partitioning, is just ignore this level for the where clause and continue going through all the tables. And then when we get the result, we just get the fraction using the modulus as I showed in the previous slides. And we come up with a pretty good estimate. So I don't have the demo, but we try to do some extensive testing, and the result was quite good. Obviously, the problem is, the problem is if you want to have like super accurate result and you try to get 100% of your 1 terabyte data, it would be super slow to do, so don't do that. Usually, like getting 10,000 rows should be enough to come up with pretty good estimates. Maybe not if you have weird data distribution, but most of the case it should be okay. So next, so we have enough information to tell Postgres what are the statistics like, so we can come up with a good plan. So now the problem is how to fake the planner to say this is not a real table, but this is magically a partition table as you declared it, and do it the same way you would do if it was really partition table. So to do that, we use 4 different hooks. It was 5 in Postgres version 10 because it changed during version 11. But I will focus mostly on Postgres version 11. So the first hook is a process utility hook. So do you already know some Postgres hooks for if you write some extension and stuff? Like someone already know some of these hooks? Yes, some people? Good. So process utility hook is a hook you call when you call a non-DML function, so alter table, create table, whatever, and in this case, explain. So we detect if you are using explain without analyze option, because obviously we can't execute the query with fake partitions. So if we detect we were in explain without analyze, then we use get relation info hook, which is a hook called when you get the basic information of one table, which is like the list of indexes, the size, and everything else. So we just hook at that point and just inject a lot of things. So basically, we try to come up with the same structure in the planner that would have been generated. So we kind of like rewrite a lot of things. If some people know, we just get the range table entries and we add a bunch of entries, change the inherited things and everything. And so at first you have like the real table with statistics, and when we inject it, we now have like the table, which is a root table, which we will say to Postgres it's empty, and instead add all the partition or sub-partition tables. Then, if you call HypoPG analyze function, we will use get relation stats hook, which is a hook called by Postgres when you want to retrieve the statistics. So that's why it's stored by a standard analyze operation, but that's why we overload. So we just retrieve what we stored in local memory to inject it by Postgres. And so it's, So that's all for version 11. For version 10, we also call set role pass list hook, which is used for pruning, partition pruning. But it's because in version 10, the pruning is done using constraint exclusion, which is working, but it's super slow. So we use the same like dummy relation thing. But in Postgres 11, the partition pruning is done using the partition scheme data. So it's super fast, and we don't need that anymore. And then we are done. We just, like the planner, all the information planner are as they're supposed to be as for real partitioning. So Postgres will just continue the execution, do the standard planning and everything, and come up with the results. And you just get the query plan back and see how Postgres should have behaved with your hypothetical partitioning thing. So I had some demo, but I can't do it right now. So I think I have more, yeah. So there are some things we do support and something we don't support. So the thing we do support is like select queries. You can simulate all the partitioning strategy, so range, list, and hash. We support like partition pruning, so plan time partition pruning and runtime partition pruning with the same technique as vanilla Postgres. Partition-wise join and partition-wise aggregation are supported. Multiple-way join are supported. Parallel queries with partitioning everything should also be working. You can simulate insert queries on hypothetically partitioned tables. This is working, but update and delete queries are not supported. We can't support that for now. It's because the hook I was talking about as a get relation info hook is not really called the same way for update and delete. So what we would do in this case is generate an append plan, and when you do an update and delete, you just have like the modify nodes instead of plan thing, append thing. So you have different output, which does not really make sense. So we prefer to just refuse executing this kind of query instead of showing additional nodes, which could be really bad. So we hope we can fix it for Postgres 12 or 13 to make it work better, but for now it's not working. So you can also do multi-level partitioning, so you can partition a partition. You can also do a default partition. And one thing I learned is you can partition your default partition, and probably you can have a default partition for your default partition, which is weird, but that's apparently supported. And also one thing's nice, it's you can create hypothetical indexes on hypothetical partition. So you can at the same time say, oh, I will partition like this and add specific index, hypothetical index on each partition for your query. So you can test both of them at the same time and come up with like a huge DDL to pass at night. So as I said, the limitation, you can only do that for plain table, which means if you have old style partitioning or declarative partitioning, you can't really like unpartition and partition it in a different way. We don't really plan to handle that for now because it would be quite complex, and that's probably something no one will really want to test anyway. So, but if you need it, tell us and we'll try to find a way to do it. Another problem is we can't really change a table name in the output because Postgres doesn't really support that. It's possible for index, but for table you can't do it. So what we're doing is adding an alias clause. So if you do hypothetical partition on T1 and you add T1A, T1B, and blah, 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 what you will see in the explain, you will see like a sequential scan on T1 and then T1A as the alias. So it's a little bit different, but you still know which table is used, which table is pruned or not pruned, so it's good enough for now. we will try to come up with a patch for hackers on Postgres to support this kind of thing, but not yet. So we do not support update and delete. And for now, Postgres 12 is not supported yet because, once again, a lot of things changed. So all the headers changed, new function and everything. So we really focused on being able to come up with a beta version and working on already production-ready version of Postgres, but we will add it as soon as we can. Okay, so what next for HypoPG hypothetical partitioning? For now, it's a little bit hacky because what we do to simulate the partitioning expansion is we just rewrite as I said, the entry. So if you know it is a simple RTE array, so we just make it bigger and add a bunch of stuff. So it's hacky. So it's not really something you would like to do normally. So it's the only way for now to do it. So we want to try to come up with a better integration. So it should be doable as an extension without overwriting this kind of arrays in the planner. We also want to support update and delete queries because it should be like very important for your workloads to see how it's behaving. Obviously, support Postgres 12 and all the other functions. And once all of this is fully working, what we want to do is try to add some kind of advisor, which would be able to watch all your queries happening on your production server, kind of inspect all your tables and say, oh, you have like one big table. You always query using this or this field, so maybe you can partition with it. It could be a good idea. And then automatically detect it, try to partition with that and show you the query plan and say, oh, like if you do that, it should come up with a pretty good query improvement, so maybe it's a good idea to do that. So we plan to do it, but it's obviously not done yet. And this will probably be done with a PGConf.Russia extension. So it's an extension we just do the same as PGStat statements, but on the predicate, so the where clause and the join clause level, and you got a lot of statistics for that. Okay, so as a summary, so with HypoPG, so you can support hypothetical indexes, hypothetical partitioning. You can come up with a lot of different partitioning strategy in a short time without spending a lot of resource. Yeah, so it's in beta for now. So we try to do extensive regression tests, but we always find like some workloads may be different. So if you want to try it, if you maybe need this kind of tool, you please try it and give us some feedback so we can know if it's working as expected, if it's like if it's slow or whatever, so we can optimize it. So any feedback is welcome. So I'm a little bit short because I didn't have the demo, but if you have any questions, and also feel free to send mail or message on Twitter if needed. And so thank you.
Если есть вопросы, задавайте, поднимайте руки.
Shall you have any questions? You are free.
I was wondering if it's safe to leave it running in production because it creates a hook which is, I assume, is global, so you probably want to disable it after you're done with your testing?
Oh, it's by default it's not loading on your backend. So what you want to do is like load HypoPG, or it's automatically loaded when you call one of the functions. So it's only loaded in one backend. So you won't have it's only in backend local memory, so all the other backends is totally transparent, you won't have anything. The only risk would be like if there is a bug and if it crashes, your whole cluster goes down. So That's the only risk. But for now, we are segfault free, so hopefully it's okay.
Thank you.
Ну, если нет вопросов, давайте еще.
So if you don't have any questions, thank you very much. It was a pleasure.